Today we're going to go over how to do the component method for scalars and vectors. So it says find 3b minus 2a using the component method. So first we would have to write b vector equals 30 meters, 60 degrees, and then a vector equals 50 meters at 0 degrees. So then we would have to convert these into, we just multiply by 3 and negative 2. So 3b would be 90 meters at 60 degrees, and negative 2a, we would multiply the front number by 2, which would be 100. And then we would have to, because it's negative, we would have to go to the other side of the graph, so it would be 180. Okay, then we need to draw the vectors. So 3b would be somewhere around here, and negative 2a would be somewhere around, it would be this line right here. Okay, so for 3b, we want to, okay, so for 3b, we first want to draw the triangle. So it would be like this. Then this would be, the resultant would be 30, or the reference. Then the magnitude would be 90. And then this would be x, and this would be y. And then for this one, negative 2a, since it's just going left, it's just going to be 100, and then at 180 degrees, or 0 degrees for the reference. So we need to find the x and y's. So first, to find x here, we need to use sine. So it'd be sine 30. Sine 30 equals x over 90. And then we would write x equals 90 times sine 30. For this, we already know that it's going to the left and the magnitude is 100. So x is just negative 100. And since it's just going left at 180 degrees, the y is just 0. So to find y here, we would have to use cosine. Cosine 30 equals y over 90. And then it would be y equals 90 cosine 30 degrees. All right. Okay. Since we have both the x and y for both the equations, we would just have to write the sum of all the x's, which would be 90 sine 30 degrees plus negative 100. And same for y, it would be 90 cosine 30 degrees plus 0. And I know the answers for these are negative 55, and this would be 77.9. Okay, now, since we have the sums of the x and y, we can draw the resultant triangle. So this would be sum sketch. Okay, so since we always start with x, we always start with drawing x. So since the x is negative, we would have to go this way. And since the y is positive, we would have to go this way. And the resultant would be like this. Okay, and we do not know theta, which we're going to find for the direction. And we do not know r, which is the resultant. vector, and we know this is 77.9, and we know this is 55. Remember to not put the negatives on here because it already shows, the arrow already shows the direction. Okay, so to find the magnitude, we would first have to do the square root of negative 55 squared plus 77.9 squared. And I know this equals to 95.4, and that is our magnitude. And for theta, we are going to find it by doing the inverse tangent of the opposite over the adjacent. So it'd be 77.9 over 55. So the data for this would be, it would be 54.8. However, this is just for the resultant, the reference. So we would just have to add, or 180 minus this number so that we get it in the second quadrant. So we do 180 minus 54.8. This would be 10. Okay, so it'd be 125.2. And then when we are writing the answer, we'd have to write it as R with the half arrow on top equals the 95.4, which we got here. And do not forget the units, which is meters, at 125.2 degrees. Since it's a vector, we need to find the direction as well. And another way you can write it is with the northwest southeast. So this particular one would be the north and then west. So it'd be north, west. And since we're looking at the northwest, not the north or west north, we'd have to use this angle right here instead of this. So we would have to do 90 minus 54.8, which I found was 35.2 degrees. And that is our final answer for this problem.